George is the science boy.
George Boyd's the science guy.
George
Boyd the science guy.
Science rules.
George Boyd the science guy.
Inertia is a property of matter.
George Boyd the science guy.
Boyd is the science boy.
Boyd.
Okay, hi everybody. In this lesson what we're going to do is we're going to talk about how to calculate relative humidity, which is how full the air is relative to its temperature and how much it can hold, and how to calculate the dew point, which is the temperature at which the air is full. The way we do this is we use an instrument called a sling psychrometer, and let me show you what that is. This is a sling psychrometer. And what it is, it's a stick, and we spin it around in the air. It's got two thermometers. This is a dry bulb. This is a wet bulb. And the dry bulb simply tells the temperature of the air. The wet bulb, this is a little piece of cloth that's dipped in water. And as water evaporates off of this, it draws heat out of the thermometer and causes the temperature to go down. So if the air is soaking wet, it's saturated, you're not going to get any evaporation, and this temperature isn't going to drop. If the air is very dry, you're going to get a high rate of evaporation off of this, and this temperature is going to drop. So the difference between this temperature and this temperature is an indicator as to how dry the air is. So what this looks like, if you take the dry bulb and the wet bulb on our sling psychrometer, okay, there's the dry bulb. This temperature is always going to be higher than the wet bulb because there's no evaporation occurring here. As water evaporates off of the wet bulb, depending on how dry the air is, this temperature is going to drop. So this temperature right here is called the wet bulb depression because it went down. So this is the wet bulb depression, and the difference between the dry bulb and the wet bulb, okay, you get from subtracting. So you take the smaller number, subtract it from the bigger because you always want a positive for the difference, and this is called the wet bulb depression. Okay, so the only math that we have to do here is subtraction. So the dry bulb is the air temperature, the wet bulb is the temperature of the thermometer as water evaporates off of the bulb. As water evaporates, it draws kinetic energy out of the thermometer, and the wet bulb depression is the difference between the wet and dry bulb. You simply subtract. So we're going to go down here. Okay, this is a chart in your reference table. Now there's two charts. There's this chart for the dew point, and there's this chart for the relative humidity. They're used the same exact way. It's just that you use one chart to get the dew point, the other chart to use for the relative humidity, and both of them use the measurements from the sling psychrometer, the wet and dry bulb. So when we look at this, what happens is you use your sling psychrometer, we get a dry bulb, which is the air temperature, and we get a wet bulb, which is the air temperature drawn down by the evaporation. So here's the dry bulb, here's the wet bulb. You subtract to get the difference. Then what you do is you go to the chart. Now, the biggest mistake that people make, they see dry bulb over here. Okay, let me just get this. See dry bulb over here. And what they do is they go down, they go to 16, there's the dry bulb, then they go over here to the dew point, the top, the x-axis for the dew point, and they say, oh, we have a dry bulb, we have a wet bulb, so the dry bulb was over here, the wet bulb must be over here, so they go to 12. You go down, go across, and they assume that's where you find your answer. When you take the Regents exam, there will be multiple choice questions like this, and they always put that wrong answer. The correct way to do it is to use the dry bulb, and not this number, but this number, the wet bulb depression. Okay? In everyone's reference table, when we're in class, I have them circle the word difference. This is the dry bulb, however, this is not the wet bulb. This is the difference, so you have to subtract these two. So you take your dry bulb, go to 16, read across, go to the wet bulb depression, which is 4, find it up here, and wherever they meet, that's your answer. So your dew point is 9. That's the temperature at which the air is saturated, and that's when we'll have rain. So right now the air temperature is 16. It would have to drop, get colder, down to 9, and at that point we would have 100% relative humidity and we would get precipitation. Now it doesn't have to always reach exactly that number. As we approach that number, our chances of having rain increases. Okay, the other chart, relative humidity, it's the same exact way. What you do is on top you have the difference, on the left you have the dry bulb, and wherever they meet you'll get a percentage of how full the air is. So let me just show you that. So we would use this chart. Let me clear this out. It would be the same exact numbers. We would go to 16 over here. We would go to 4 for the difference. You read down, read across, and what this means is the air is 62% full. As the air temperature changes, the percentage changes. Okay, so this is dew point over here, this is relative humidity. The reason why there's no numbers up here is because these conditions don't exist in nature. All right, so hopefully that made sense, and we'll do some practice calculations.